Are you smarter than Mr. Rebong? On the right we have Orphe and Centroid. Team hashtag better together. And here we have Emmy and Sophia as team hashtag wait for the right moment. Alright, let's get this game started. Presenting all the problems tonight, we have the lovely Big Bertha.
Okay, first question. Prove that quadrilateral crab is a parallelogram.
First, you should label all the points. This is C, 3,5, R, 4,1. This is A, -3, -3. And that's B, -4, 1.
Amazing job. Baby team, hashtag better together can get it next time.
Maybe they will. I wonder what the next step is. There's so many ways to prove that a quadrilateral is a parallelogram.
I wonder which way we can use.
Well, we can find two sets of opposite congruent sides.
Or you can find two sets of opposite congruent angles.
You can find one pair of supplementary consecutive angles.
Or you can find if the diagonals bisect each other.
Or you can find two sets of opposite parallel sides.
And one pair of sides that are both congruent and parallel.
What should we do?
I wonder what. Is it logical to use the proofs involving angles? After all, this is a coordinate geometry proof.
I agree, and it would also be a lot of work to find the length of both diagonals. I think it would be best if we found a pair of congruent and parallel sides, and that way we can use two formulas when we solve it. Now that you have chosen your strategy, you can begin to solve the problem.
So in order to find one pair of congruent sides, we need to use the distance formula.
Distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared. That's the distance formula.
Okay, so here we have the distance formula, and we're going to be finding the distance of CR and AB. So first, let's write out the points. So point C is 3,5, point R is 4,1, point A is -3, -3, and point B is -4,1. So first, let's find the distance of CR. So let's plug them into the formula. So it's x2 minus x1, so it's 4 minus 3 squared plus 1 minus 5 squared. And then that simplifies to 1 squared plus -4 squared, which simplifies to 1 plus 16, which simplifies to radical 17. So the distance of CR is radical 17. Next, let's find the distance of AB. So it would be -4 minus -3 squared plus 1 minus -3, which you can just write as 1 plus 3 squared. And that would simplify to -1 squared plus 4 squared, which simplifies to 1 plus 16, which simplifies to radical 17. So the distance of AB is radical 17. We know that radical 17 is equal to radical 17, so that means that side CR is congruent to side AB. Okay, now that we've proved that side CR is congruent to side AB, all we need to do is prove that side CR is also parallel to side AB.
And to prove that lines are parallel, we have to use the slope formula.
I'm gonna find the slope, cause I got the formula in my pocket. M equals y2 minus y1 over x2 minus x1.
So we have the slope formula over here, and right now we're just writing down the points. So C is 3,5, R is 4,1, A is -3, -3, and B is -4, 1. Now we're just labeling x and y. Okay, now let's find the slope of CR. So let's plug in the points. 1 minus 5 and 4 minus 3, which equals to -4 over 1. And so the slope of CR is -4. So let's find the slope of AB. So plug in the points again, and 1 plus 3 over -4 plus 3, and which equals to 4 over -1. So the slope of AB is -4. Since the slope of CR and AB is -4, they are parallel. So now let's put it all together. We know that quadrilateral crab is a parallelogram because it has one pair of sides that are both congruent and parallel. Sides CR and AB both have a length of radical 17 and both have a slope of -4. Therefore, sides CR and AB are congruent and parallel. Now we've proved that quadrilateral Crab is a parallelogram.
Now it's time for hashtag Better Together to solve the next problem. Can you help them?
Midpoint, what do? Add them up and divide by 2.